This conference will now be recorded.
Morning, students. Today we are going to discuss about inductance of a three-phase line. So in last class we discussed two concepts. So one is the three-phase conductors, that is R by P. We are placing in symmetrical when it is placing in unsymmetrical manner. We found that what is the inductance about two cases. So when the three phases R by P is placed as a symmetrical spacing in arithmetic, the three conductors are placed among the other conductors with equal distance. Suppose the distance between R by is same distance between YB and BR. So when the distance between the three conductors are same, then it is called as symmetrical spacing. If it is not equal, then it is called as unsymmetrical spacing. And we derive that what is the inductance in both cases. Now, in today's class, we discussed about the same thing, the three-phase line, three-phase line placing in unsymmetrical manner, but transposed. So, what is the intention? We will go move for transposition means. We will discuss it. Then. So, these are the two topics we are going to discuss in today's class. See, in last class we derived the two equations. One is inductance of a three phase when the three conductors are placed in a symmetrical manner. So symmetrical manner means equal distance. At the same time, we discussed when the three conductors are placed in unsymmetrical manner, it means that unequal distances between the three conductors. Now, if the three conductors are placed in unsymmetrical manner, there are some drawbacks will be occur in the transmission system. So what are the drawbacks means? If the three conductors R by B is placed in an unsymmetrical manner, the receiving end will not get the proper output. Suppose if you so we are facing different difficulties in that. So in sometimes instead of these three R by B, one phase is not coming there. ఓకేనా మనం ఎప్పుడైనా వచ్చేటప్పుడు ఆర్వైబిలో ఏదో ఒక ఫేస్ ట్రిప్ అవుతా ఉంటది ఆర్ ఫేస్ సప్లై రాకపోవడం కానీ వైఫ్ ఏదో ఫేస్ సో ఎందుకంటే దిస్ ఈస్ ద రీజన్ when three phase conductors are placed in unsymmetrical manner, that is unequal distance, the receiving end side we are not getting the proper output. So how we can rectify this problem is there is only one way. We have to transpose the three phases RYB. We have to transpose. Transposition is nothing but position will be changed. So I already said that what is the difference between transposition and transfer. Transpose and transfer means transfer is nothing but it is a replacement for one place to another place. Transposition means it is replacement of one state to another state, one position to another position. Suppose if we take that ice cube, so if we play, so at starting it is in solid state. When we keep in temperature, it will convert to the liquid state. So it means that changing the state, that is called as transposition. At the same time, if you take the water, if you drop the water in one place, it will travel from distance. So that is called as transfer. So that is the difference between transposition and transfer. Now, the fault, that is the drawbacks we are facing from the unsymmetrical spacing. How we can rectify means by the transposition. So that is the topic we are going to discuss about. Inductance of a three-phase line with unsymmetrical spacing but transposed. In this condition, we can obtain that perfect output. So let me see that how the transposition is placing in the transmission line. So are you all seeing this page diagram here? This is the three conductors. I am taking that R, Y, B, and these three conductors are placing in unsymmetrical manner. It means that the distance between R and Y is different when compared to the distance between YB and BR. Now, in this case, if we are not using any transposition in that phases, we are not getting proper output in the receiving end. So how we can rectify this problem is by meaning of transposition. So let me see that how the transposition will be occur. Now see this diagram. This is the sending end. So here RYB is there. Now if this R by B is not change its position, so suppose R is same, we have the same position, so let's consider this position 1, position 2, position 3. If R is same position until the receiving end, similarly by B we are not getting the proper output. Why? Because these three phases are unsymmetrical manner. If three phases are unsymmetrical manner, their inductance is difficult to calculate. So already we derived the two derivations for symmetrical spacing and unsymmetrical spacing. For symmetrical spacing, we obtained 2 into 10 power minus 7 dm by ds. So in the symmetrical case, you can easily calculate that value of inductance. But in the case of unsymmetrical space, it is difficult. So how to rectify this means by transposition. So this is the position 1, position 2, position 3, and so this position will be changed based on the distances. Suppose from source to load it has 40 kilometers. So we are placing that 10 kilometers, separating the 10 kilometers from source to 10 kilometers. The position of R by B should be like this: position 1, 2, 3. After certain kilometer, the position will be changes. So in first case R is first position, so in second case it will come 2, 3. So it is out. Finally you will get the same R by B. What we will have the receiving end side, same thing we will. So in between this, that R by B phases are transposition. So due to this type of connection, we can get that perfect output from to the load side. So how we can transposition will be changes means, suppose it is R by B. Here R is in position 1, Y is in position 2, and B is position 3. And after 10 kilometers, it should be changes with respect to the clockwise direction. So when it is rotating in clockwise direction, R becomes to second position, Y becomes to third position, B becomes to first position. The same thing happening here. Similarly, until we have to place in this phases, still the initial position. So this is called as transposition, and you may get 2 marks question on this. What is the main advantage of transposition? So it has the two advantages. One is by the transposition of three phases, you will get that perfect output to the receiving end, get that to the receiving end. And second one is we can easily calculate that inductance value. So this is the two reasons why we choose that transposition of R by B. See, this is the position we are placing the transposition of R by B in the transmission lines. So let's consider this position 1, position 2, position 3. So this is the positions in the source side, that is in generating side. So let conductor X, conductor Y, Z. After certain distance, its position will be changed. So 1, 2, 3. So X will come 1, 2, 3. Y will come 2, 3, 1. Z will come 3, 1, 2. This is the positions of R by B with respect to the transposition condition. So this is called as transposition of three phase line. Now let me see that how we can calculate that inductance value, flux linkage value, and what are the advantages of transposition. Ushama sir, do you have any doubts?
No doubts.
Right. So we'll go for topic. So these are the two topics we are going to discuss in today's class. One is inductance of a three-phase line with unsymmetrical spacing but transposed. So when the three conductors are placed with unequal distance, so that conductors should in a transposition manner. And second one is inductance of a three-phase double circuit with symmetrical spacing. So these are the two topics we are going to discuss in today's class. Right. See, here what is the why we choose for transpose means this is the reason. Here we are facing the problem to find out the inductance in case it is difficult. So if we are not using the transposition, it is very difficult to find the inductance value. So how to rectify this value, this problem by transposition. And the flux linkage and corresponding inductance will not be same in each phases. Why? Because the distance will be differences. And due to this different inductance per phase, there is an unbalanced condition will be occur. But in the case of current, the three currents are flowing in the same balanced condition, IA, IB, IC, or IX, IY, IJ, based on our notation. And the drops in the three phases due to this inductance. Why? Because, for example, if you take that R by B, due to this unequal distance, the drop will be different among these three phases R by B. Due to this drops in three phases, the inductances are observed into the different. Due to this condition, the receiving end will not get the same voltage. సో అందుకని మనకు ఒక టైంలో ఏదో ఒక ఫేజ్ లో వోల్టేజ్ తక్కువ వస్తుంటుంది. సో at that condition we can't able to use the three phase supply. So how we can get that, how you can resolve the problem is by using this transposition. Next, so this is the arrangement of transposition, that is R by B conductor, and with respect to the positions. So this position will be changed at a certain distance L by 3. So it has that it will take the three parts, and three parts will be divided by L by 3, L by 3, L by 3. So this transposition will be occur at equal distance. If you are not placing in equal distance, then there is some variations will be occur in the inductances value and flux linkage value. So we have to make this transposition with fixed distance, 10 kilometer or 15 kilometer, 20, whatever it may be, but you have to transpose in with respect to the equal distance. Suppose if it is 100 kilometers, you have to take that 5 parts, then 20, 20, 20 like that. You have to replace that. And our final condition is, what is the phases position in the source side? The same will be in the receiving side. Then only it will get that proper output. Next, the positions of conductors are exchanged at a regular interval along the line. So, for example, after 10 kilometers, the position of X will be changed, means automatically Y, Z also changes. So it means that with respect, all phases will be changing with respect to the regular interval after 10 kilometers, after 20 kilometers, after 30. And due to this position is called as transposition. So one place nunchi ingo place ki ledani transposition antaru. Due to this, the balanced condition will be occur in the three phase system. So this is a reason. And one more thing, the transposition structure we seen in the previous slide. What is the position of X, Y, Z in the transposition condition? Now, after finding this, what we are going to derive here means, suppose we have to consider the X phase. So at first distance, it is in position 1. After first interval, it is in position 2. And after that it is position 3. It means that the X phase is keep on going to change at a regular interval. So what we have to find, if you want to find that flux linkage of A, what you have to do means we have to calculate that what is the flux linkage of A at position 1, and next what is the flux linkage of A at position 2, what is the flux linkage of A at position 3. We have to calculate that three positions of X conductor. After that, we have to find that total phi x value by taking the average value plus divided by 3. Why? Because these conductors are in parallel connection. So this is what we have to find. Similarly, if you want to find that inductance of a conductor X, we have to calculate inductance when X is in first position. Similarly, inductance when X is second position and third position. After that, we have to take that average value for finding the total inductance and total flux linkage of a particular conductor. Now, see here, this is the we are finding that what is the flux linkage of X. So this is what we have to find out. At first, so we have the three X, Y, Z, right? X, Y, Z. At first interval, these three are in this position. So this is called a first interval. In this condition, X is in position 1, Y is in position 2, Z is in position 3. For this, we have to make the flux linkage. So this is the inductor X, and it is the position 1. So side X1. Now we are finding the flux linkage of X with respect to the Y and Z. Now let me see how the equation will become. So we have the equation, right? Flux linkage pi x1 is equal to 2 into 10% is common for all things, and into ix ln of 1 divided by self distance of X is 1 by r dash plus iy ln 1 divided by the distance between x with respect to y, d12. Similarly, plus ij into ln of distance between x and 3. So this is the equation when x conductor is in position 1. Similarly, if in second interval, what will happen? So that the x will becomes in second position, y becomes in third position, z becomes in first position. So this is the positions of z, x, y. So 1, 2, 3. So in this case, what we have to find, we will see this in next slide. So this is the equation of flux linkage when conductor x in first position. Now after first interval, so it will comes to second interval, right? At this interval, the conductors xyz will be transposed its positions. So this is the equation we can append. See here. In first case, x is in position 1, but in second case, it will transpose to position 2. Y is in first position, second position, it transpose to 3, and z is in 3 to 1. In this condition, we can write that derivation. So this is the flux linkage of x when it is in position 2. 2 into 10 power minus 7 ix ln. So the same self distance 1 by r dash plus iy ln. So what we have to do means, suppose just compare that. So it is in x is in first position, 2 this is the 3 in z position. So instead of this one, you have to replace that. So when it is iy, that ln into 1 by 2 d23. So x y z. So this is 1 2 3. After that 2 3 1. Next 3 1 2. Now in first case, what we found that equation pi x1 equals to 2 into 10 power minus 7 ix ln 1 by r dash plus iy ln 1 divided by d12 plus I2 ln 1 divided by d31. Right, d13. So this is the equation we obtained in first case. Now what we have to do means, see in first case we have 1 2. Second case what will come 2 3. Here first case we have 1 3. What will come 2 and 1. So after 1 2 3, so it is keep on going to increase that. For example, if you want to find the pi x3, what will get 2 into 10 power minus 7 ix ln 1 by r dash plus iy ln 1 divided by d into, here after 2 what you will get 3. So d31 plus ij ln into 1 divided by d32. So that's what you have to. So you have to the numerical values keep on going. So if it is 1 in next cycle, it will become 2. If it is 2 in next cycle, it will become 3. If it is 3 in next cycle, it will come 1. So that's you have to remember that. Now this is the flux linkage when the conductor x in position 2. Now we'll see that when the conductor is in position 3, you will get replacement of xyz is like this. So 3 1 3 3 2. So 3 1 and 3 2. So after finding this 3 flux linkage with respect to the positions, if you want, we have to find that total flux linkage of x conductor. So we for this condition we have to find that what the total average of all flux linkages with respect to the positions, pi x1 plus pi x2 plus x3 divided by 3. Now after that, pi x is equals to 2 into 10 power minus 1 by 3 into, so I already said when the logarithmic value in the addition, we have to multiply that, or else if the logarithm function is subtracted, we have to division that, right? It's the same thing. When we observe these 3 equations, the first term is common in 3 equations. So that's why I am writing here the addition of 3 into ix ln 1 by r dash plus iy into ln 1 divided by So in first case we have D12, D23 and D31. So these terms are in addition. Now if you want to reduce this equation, then it will comes to multiplication. So how it means ln 1 by a, ln 1 by a plus ln 1 by b. What you will get? ln 1 by b, 1 by ab. The same thing I substitute here. Similarly, ij equals ij ln divided 1 divided by d13, d21, d32. Now, if you want to find that lx value, what we have to find? We have to bring this equation in terms of pi x divided by ix. Then only you can calculate that what is the inductance of a conductor x. Now, here we have the currents iy and ij. Now we have to make this IYZ as a IA. So I already told you that how we can remove these two currents means if the unsymmetrical phases are transposition, then it makes the balanced condition. If we are not placing the transposition, then you can't able to rectify this problem. So we have to find that IY by IA, like that we have to find. But here, due to the transposition, the balanced condition is maintaining here. That's why we are carrying that this condition Ix plus Iy plus Iz equals to 0. If we are not placing the transposition, it is not occurring the unsymmetrical spacing, right? So now in these two terms, these two terms are equal. So that's why I'm taking that Iy plus Iz is a common for this term. Then when eliminating this term with respect to the IA, then you can get that total current. So how we can eliminate this means by taking the balanced current condition Ix plus Iy plus Iz is equal to 0. From this condition, we can replace this Iy plus Iz is equal to minus Ix. If you substitute this equation, let me see what we'll have. So after substitution of Iy by plus Iz is equal to minus Ix, I have substituted here. Now we got this one. Still there is an unbalanced condition in this equation. Still it is not balanced equation. Why? Because at first term it has the 3 value, at second term it is 1 value. The coefficient of Ix is 3, here 1. We have to eliminate this 3. How we can eliminate means, first of all, take the Ix is common here, then you will get equation like this. Next, when we multiply this entire term with respect to the 1 by 3, 3 get cancelled, and here it is multiplied with 1 by 3. Now 2 ln x, what you will get? 2 ln x, you can write this ln x square, right? So you can replace this equation like this. Similarly, here 1 by 3 ln x, what you will get? Ln x power root 3. So that is the reason we are applying here. And these two terms are in subtracting each other. So if you want to make this one term, you should have to use 1 by a by 1 by b. So finally you will get this inductance of a conductor x is given by 2 into 10 power minus 7 log Deq divided by R1. So numerator is called as mutual GMD and it is called as self GMD. This type of equation we obtained when we are using the symmetrical spacing, but here we are using the unsymmetrical spacing, but it's transposed. That's why we are getting the same equation what we obtained in a symmetrical spacing. So that is the main advantage of transposition. So transposition has the two advantages. One is we can easily calculate the inductance value, and second one is we can maintain the balanced condition. Third one is we can obtain the proper output at the receiving end. Now, in a similar way, we can obtain for Ly and Lz. Right. So now next topic is inductance of a three-phase double circuit with symmetrical spacing. So what is the advantage of double circuit? So I already told you that in yesterday class. What is the advantage of double circuit in three-phase transmission line?
To transfer bulk power, sir.
Right. So it makes a what need transposition, right? So transposition is need for maintaining the balanced condition first. So transposition అనేది ఏ కండిషన్ లో యూజ్ చేస్తారంటే ఎప్పుడైతే త్రీ కండక్టర్స్ అనేవి అన్సిమెట్రిక్ అంటే అన్ఈక్వల్ డిస్టెన్స్ లో ప్లేస్ చేస్తారు, ఆ కండిషన్ లో మనం ట్రాన్స్పోజిషన్ ప్లేస్ చేస్తాం. సో ట్రాన్స్పోజిషన్ వేయడం వల్ల ఏమవుతుందంటే బ్యాలెన్స్డ్ కండిషన్ మెయింటైన్ చేయొచ్చు ఫస్ట్ ది. సెకండ్ వచ్చేసి మన ఇండక్టెన్స్ ని ఈజీగా క్యాలిక్యులేట్ చేయొచ్చు. థర్డ్ వచ్చేసి ఈ విధమైన ట్రాన్స్పోజిషన్ ఉండడం వల్ల మన అవుట్పుట్ అనేది ప్రాపర్ గా ఉంటుంది, అంటే 3 ఫేసెస్ లో ఈక్వల్ వోల్టేజ్ ఉంటుంది. ఒకవేళ ట్రాన్స్పోజిషన్ లేకపోతే RYB లో ఏదో ఒక ఫేస్ లో వోల్టేజ్ డ్రాప్ అనేది జరుగుతుంది అనమాట. సో దట్ ఈస్ ద ఇంపార్టెన్స్, దట్ ఈస్ ద నీడింగ్ ఆఫ్ ట్రాన్స్పోజిషన్ ఇన్ unsymmetrical spacing conductors. Okay na? So that is the need we are using transposition. Now, so until now we discussed in the single circuit. So actually గా మనం 3 phase transmission అనేది డబుల్ సర్క్యూట్ యూజ్ చేస్తారు. డబుల్ సర్క్యూట్ ఎందుకు యూజ్ చేస్తారంటే ఇఫ్ దేర్ ఇస్ ఎనీ ఈవెంట్ ఆఫ్ ఫెయిల్యూర్ ఆర్ రిపేర్, సపోజ్ మన టూ సర్క్యూట్స్ ఉన్నాయి అనుకోండి, ఏదో ఒక సర్క్యూట్ ఫాల్ట్ అయినా కానీ దాన్ని రిపేర్ చేయాలన్నా కానీ ఏమవుతుందంటే సప్లై అనేది ఇంటరప్షన్ కాకుండా ఒక సర్క్యూట్ నుంచి యూజ్ చేసుకోవచ్చు అనమాట. సో అలా చేయడం వల్ల ఏమవుతుంటే వీ కెన్ మెయింటైన్ ద రిలయబిలిటీ. So that's why in 3-phase transmission lines mostly we are using the double circuit for backup purpose. If we are using the double circuit, so we can maintain the reliability. Until now we discussed about only one circuit in the 3-phase line. Now we are finding the inductance of double circuit. Well, if it has a double circuit, we are considering the two circuits when it is facing symmetrical, unsymmetrical. Okay now? Now let me see that importance of a double circuit. The first one is it gives the more reliability and high transmission capacity. So that is the reason, and we can easily calculate GMD and GMR for phase by considering various conductors connected in parallel. Strands of one composite conductor. అంటే ఒక కాంపోజిట్ కండక్టర్స్ లో స్ట్రాండ్స్ ఎలా కనెక్ట్ అయి ఉంటాయో అలాగే ఇక్కడ ఎలా అంటే చూడండి. సో దిస్ ఇస్ ద టవర్ హియర్, and inside one side there is a one circuit, other side of the circuit too. It has the 3 phases, and the 3 phases are bundle conductors. So bundle conductors అంటే ఒక సర్కిల్ లో 3 లైన్స్ కానీ 4 లైన్స్ కానీ వెళ్తా ఉంటాయి. అలాగే సో RYB సిమిలర్లీ RYB అని ఒక సర్క్యూట్ లో ఉంటుంది. సో ఇక్కడ వచ్చేసి జాగ్రత్త, మీకు ఆల్రెడీ చెప్పాను, ఒక సర్క్యూట్ లో RYB ఉంటే RYB ఈ విధంగా ఉంటే ఇంకొక సర్క్యూట్ లో వచ్చేసి RYB అంటే డౌన్వర్డ్స్ నుంచి ఉంటుంది. ఇలా చేయడం వల్ల అడ్వాంటేజ్ ఏంటంటే actually what is the purpose of this type of position means, suppose if you take that inductance value 2 into 10 power minus 7 ln dm by ds. సో dm అనేది ఏమవుతుందంటే GMD calculation. So that is mutual GMD and self GMD, that is GMR. సో ఇప్పుడు మీరు ఈ న్యూమరేటర్ డినామినేటర్ బేస్ చేసుకొని ఇండక్టెన్స్ వాల్యూ మనం ఫైండ్ అవుట్ చేయొచ్చు. యాక్చువల్ గా ట్రాన్స్మిషన్ లైన్ లో డ్రాప్స్ అనేది తగ్గాలంటే ఏం చేయాలంటే ఇండక్టెన్స్ ని రెడ్యూస్ చేయాలి. If we reduce the inductance value, we can reduce the losses occur in the transmission line. How we can reduce the inductance in direct by conductor placement means, if you are reducing this GMR value, then automatically inductance will be reduced. So that's why in 3-phase double circuit the position of RYB will be differ when compared to the circuit 1 and circuit 2. ఎందుకు ఇలా చేయడం వల్ల అంటే ఎప్పుడైతే ఇక్కడ సో ఇప్పుడు ఇలా చేయడం అంటే DMR వాల్యూ ఇంక్రీజ్ అవుతుంది, that is diametric mean radius will be increased. Other condition the inductance will be reduced another. So when the inductance will be reduced, then we can get that less losses and we can transfer the more power. So let's check also it is decided to have configuration that gives minimum inductance. ఈ విధమైన కాన్ఫిగరేషన్ చేయడం వల్ల ఏమవుతుందంటే we can reduce the minimum inductance, that we have more power transfer capability. This can be done by decreasing GMD and increasing GMR. సో ఈ రెండింటిలో ఏదో ఒకటి పాసిబుల్ అయితే మనం ఆటోమేటిక్ గా ఎల్ని రెడ్యూస్ చేయొచ్చు. ఒకటి GMD అన్నా రెడ్యూస్ చేయాలి, లేదా GMR అన్నా ఇంక్రీజ్ చేయాలి. ఓకేనా? ఇఫ్ GMD is reduced, L also reduced. If GMR increase, L also increase. సో ఇలా చేయడం వల్ల ఎందుకు మాక్సిమం పవర్ ట్రాన్స్ఫర్ చేయొచ్చు అంటే we have the formula with respect to the power, P is equals to E into V divided by X sin delta. This is the power is delivered to from source to load. So this is the equation we can write. Here P is the transferring power and E is the source end voltage, and V is the receiving end voltage, and here alpha is the angle between sending end and receiving end voltage, and X is a reactance. Suppose here when compared to the power and reactance, it is inversely proportional. If we are reducing the inductance, what will happen if you increase, if you reduce the inductance, the reactance value will be increased. So if the reactance value will be increased, the power transposition will be more. Okay, now, so here this is the power we are transferring, the transferring of power from source to load. Okay, now. Next, see here the differences between when we are placing that RYB. So suppose we are taking the two circuits. One side we have RYB, on the side we have R dash Y dash B dash. Suppose if we are using this without any changes in the position RYB, so the distance between R and R is small, and it is small, and it is small. So in this condition, the GMR value will be less. So in this condition, we have the more inductance value. When the inductance will be more, there is a huge amount of losses will be occurring in the transmission lines. So that's why we are choosing this. So this is the without using the any transposition. So XYB is in circuit 1, X dash Y dash Z dash is circuit 2. Suppose if the distance between X and X dash, so that is so we call it GMR is nothing but internal distance, ante same phase distance ni GMR antaru. ఇప్పుడు X నుంచి X dash is called as GMR. ఇప్పుడు X నుంచి Y dash కి X నుంచి Z dash కి వచ్చి దాన్ని GMD అంటారు. Geometric mean diameter. So from X to X dash is called as GMR. ఇప్పుడు ఈ డిస్టెన్స్ కనుక తగ్గిస్తే ఏమవుతుందంటే ఇండక్టెన్స్ పెరుగుతుంది. సో ఇప్పుడు ఈ విధంగా మనం ప్లే చేయడం వల్ల ఏమవుతుందంటే ద డిస్టెన్స్ బిట్వీన్ ద సేమ్ ఫేసెస్ విల్ బి రెడ్యూస్డ్. So if you want to eliminate this condition, we have to choose these positions. So in circuit, the RY, the XY, Z should be like this: X, Y, Z. In the other circuit, X1, Y1, Z1. Suppose if you want to calculate GMR, the distance will be increased here. So when the distance of increase, the GMR value is increased, automatically inductance will be reduced. Due to this reduction in inductance, we can minimize the losses in the transmission line. Now, so we are taking the two circuits. This is circuit 1 and it is circuit 2, and we are placing in symmetrical manner. Symmetrical manner means the distance, equal distance we have, and here also we can have the equal distance. And one more thing, when the inductance of a three-phase double circuit, we are placing a symmetrical manner. It looks like a hexagon, regular hexagon manner. So if you are looking this, so in circuit 1 we are placing X, Y, Z. In circuit 2 we are placing X dash, Y dash, and Z dash in downwards. Okay, now so this is the position of three phases in circuit 1 and circuit 2. Now we have to make this. What is the distance between this among this conductor? So we have 6 conductors: X, Y, Z, X dash, Y dash, Z dash. So these are the standard distance we have to maintain among these 6 conductors. So ఇక్కడ root 3D 2D is standard distance anamata. So there is no changes in the standard this distance. So if you see these distances among this conductor, the distance between X and Y is D, Y and Z is D. So ఈ విధంగా మనం distances maintain చేసుకోవాలి. So ఈ distance maintain చేసుకోవడం వల్ల if you have to find that X value, so that is the inductance of X, we have to utilize this all distances with respect to the parameters. Suppose if you want to find that inductance of conductor X, ante ee conductor ku mana inductance kanukovalante, what we have to means, we have to use that from X to X. So Ln 1 by self distance plus from X to X dash, what is the distance? So it is the distance is 2D. So this is the linkage with respect to the Ix. Similarly from Iy, from X to Y, from X to Y dash, from IZ, from X to Z, from X to Z dash. So ఈ విధంగా మనం ఫైండ్ అవుట్ చేసుకోవాలన్నమాట. See here, this is the equation of flux with respect to the flux linkage of X with respect to the all conductors. So this is X, Y, Z, X dash, Y dash, Z dash. Now the flux linkage is given by 2 into 10 power 7 is common for all terms. First one is under current Ix, due to the current Ix. So due to the current Ix, first term into 1 by so this is the X. We have to calculate x to self distance and also the distance from x to x dash. So that is given by ix. Similarly, if you want to find that iy time, you have to use that from x to y, from x to y dash. If you want to find the ij term from x to z, from x to z dash. So this is the distance what we have in the what we mentioned in last slide. So 2 into 10 power 7 ix into from x to x, the distance is self distance, that's why 1 by r dash plus the distance between x to x dash is given by 1 by 2d. So ln into 1 by 2d. So this is the ix term, and next iy term, and into ln 1 by. So here d is nothing but the distance between x to y is d, plus ln into 1 by root 3d is the distance between x to y dash. So this is x to y, and this is x to y dash. Similarly, x to z dash. Now after simplification these equations, so these two terms are having that common. That's why I'm taking that common iy plus iz. By replacing this iy plus iz with respect to the minus ix, then substitute 2 in 1. Then what you will get? Let me see. If you substitute instead of iy plus iz by minus ix, we will get like this. So this is the equation after substituting of equation 2 in equation 1. Now in these two terms we have the common term is ix. Just take the outside, then we remain these two terms. In this 2 looks like say ln a plus ln b, and these two terms will like ln a plus ln b, and these two terms should be ln a minus ln b. First we have to use this, we have to complete this term, and we have to complete this. After that we have to apply the minus. See, if you remove this plus, what we have to do? Ln into 1 divided by r dash into 2d. So this is the term we can obtain. Minus same, we have to keep same, and if you remove this term, you will get ln into 1 by d into 1 by root 3d. So you will get 1 by root 3 d square. Now these two terms in the form of ln a minus ln b. What we have to make ln a by b. So this is a and this is b. After removing this negative term, then you will get ln 1 divided by 2d. So this is the a term and b term. Finally you will get 2 into 10 power minus 7 ix ln root 3 d square divided by 2d r dash. So dd get cancelled. Finally you will get, this is the inductance of a conductor x. That is the flux linkage of conductor x. Finally you will get lx is equals to 5x divided by ix equals to 2 into 10 power minus 7 ln root 3d divided by 2 r dash. So similarly you can obtain for ly and lz. So this is for conductor x. So this what we can obtain from here. So this is the inductance of a conductor s. Similarly, so this is the inductance value for conductor. So if you want to make, so suppose x, y, z, x dash, y dash, and z dash, and this is the equation only this conductor alone. If you want to find the total inductance with respect to this phase x dash, what we have to do means we have to multiply with 1 by 2, that is 0.5. Finally we will get the inductance of each phase is given by 1 into 10 power minus 7 ln root 3d divided by 2 r dash. So this equation is alone only x conductor. This equation is combination of x dash. So that is the total conductor phase, inductance of a per phase. Similarly, y dash, z dash, we can get the same value equation. Okay, now so this is where we have to find that inductance of three-phase circuit when it is in symmetrical spacing. Now after finding this lx, ly, lz, what we have to make means we have to find that in the average value. So after finding that average value, then we can get that what is the inductance of a total circuit, that is circuit 1 and circuit 2. So for finding this circuit 1, what we have to find lx, ly, and lz. So after finding this, we have to make that average value. Finally, you will get the total inductance. So this is the inductance of a three-phase double circuit when it is symmetrical spacing. సో మీరు అబ్జర్వ్ చేసి చూడండి, ఎప్పుడైతే మనం డబుల్ సర్క్యూట్ యూజ్ చేసామో డిస్టెన్స్ అనేది తగ్గింది. సో ఇప్పుడు డిస్టెన్స్ తగ్గినప్పుడు ఇక్కడ 2 వస్తే ఇక్కడ 1 వచ్చింది, అంటే ఇండక్టెన్స్ వాల్యూ తగ్గినట్టే కదా. when the inductance value is reduced, then automatically losses will be reduced. So for reliability, for more power transfer, we had to use that three-phase double circuit with. So ఇక్కడ ఎలా ఏది అంటే the distance between the conductors will be less, and the distance suppose this is RYB. ఓకేనా. సో ఇప్పుడు మనకు రిలయబిలిటీ పెరగాలంటే ఏం చేయాలి, GMR ని రిడ్యూస్ చేయాలి, sorry GMR ని ఇంక్రీజ్ చేయాలి. సో GMR ఇంక్రీజ్ అంటే we have only condition. What is the condition means the distance between the conductors will be more, the distance between the phases will be less. ఈ విధమైన కనెక్షన్స్ ఇస్తే then we can reduce the GMR value. See here, this is RYB and it is RYB. The distance between the conductors is more, the distance between the phases will be less. So ఈ విధమైన కన్స్ట్రక్షన్ చేయడం వల్ల we can reduce the GMR value, then automatically induce the inductance will be reduced. Okay now, so that is the purpose of we are using the double circuit in the three-phase transmission line. Right. So we have only one remaining topic, one remain derivation in this inductor. What is so next derivation is inductance of a three-phase double circuit with unsymmetrical spacing and but transposed. So that is the final derivation we have in the inductance topic. After the derivation, we will discuss that different problems that is belongs to the inductance value. Okay now, after that we go for capacitance calculation. So after so in this first unit we have the two parts. One is entire part which belongs to the inductance value, second part is belongs to the capacitance value. So you may get any one question from the inductance part and one question for capacitance part. Okay now, so just keep practice all derivations what we discussed until now. So I am again remembering you what are the derivations we discussed until today. The inductance due to the internal flux, that is the first derivation. The internal flux, the inductance of a conductor due to the external flux, that is second derivation. Next, the inductance of a single phase two-wire line. Next, the inductance of the flux linkage with respect to the composite conductors, and the inductance of a composite. After that, three phase with symmetrical and unsymmetrical spacing. Next one is the inductance of three-phase circuit with respect to the unsymmetrical and transposition, and finally the three-phase double circuit with symmetrical spacing. So these are derivations we discussed until now. So just keep, after practicing these derivations, you have to make that one keynote. So for this particular condition, what is the inductance formula? For this for particular case, what is the, so we have to make the one notes for only formulas. Then only if you observe this formulas, then you can know that what is the differences among these all cases. So do this condition, write these formulas in a particular manner, then only you can understand that what is the inductance value in particular case. Okay, so this is about today class. So I will send you that material, just practice the derivations. If you have any doubts, just ask me. Right, I will send you that entire PDF until what we discussed until today. Okay now, right. So I'm going to this end this class. Do you have any doubt, students? Right, so I'm going to end this class now.